This is a rather strange question. Well, I know it's got a rational function here, r of x equals a fraction, but the question, the wording is a little strange, so we're going to have to unwrap it. The example says, solve r of x greater than or equal to 0 if r of x is equal to negative 3 over x plus 3 over minus 1 over x. The thing to remember is that r of x, just like f of x, is a y value wearing his fancy function clothes. So when they say solve r of x greater than or equal to 0, they're saying the y partner is greater than or equal to 0. And when the y partner is greater than or equal to 0, what are the x partners? That's what they're saying. So we have to consider, they give us a function r of x. They want the r of x function to be greater than or equal to 0, and they want us to find the x values where this is true. So in my own words, here's what I think they're asking, or what I know they're asking me to do. They want us to solve the following inequality, and this inequality has everything on the left side and 0 on the other side, so we're done with step 1. It's negative 3 over x plus 3 minus 1 over x is greater than or equal to 0. This is what they're asking us to do. Set r of x greater than or equal to 0 and solve for x. So they're asking us to solve a rational inequality. Now, the first thing I'm going to have to be concerned about when I get down to step 2, I have to make it into a single fraction on the left side, the other side 0. That's always where we go with step 2 in solving rational inequalities. So I'm going to have to figure out what the least common denominator is for these two fractions. The LCD. Let's see, for step 3, I'm going to have to get an LCD. One denominator is x plus 3, the other is x. So the LCD is x times x plus 3. I'm going to rewrite each of these fractions so they have the LCD on the bottom. First one I'm going to multiply by x over x minus the second fraction multiplied by x plus 3 over x plus 3 and bring down the greater than or equal to 0 sign. Now I'm going to get rid of the parentheses and I'll get negative 3x minus 3 over the common denominator x times x plus 3 is greater than or equal to 0. Then I'm going to factor the top, just simplify the top. Simplify the top. Now factor the top and the bottom. Get the negative 1 out so we have a nice expression 4x plus 3 over x times x plus 3 is greater than or equal to 0. Now take a look at what we have here. This means that the entire fraction has to be greater than or equal to 0. Essentially it's saying it has to be positive. And that's why we put the starburst around step 2. We have to remember that the entire fraction written as a single fraction has got to be greater than or equal to 0, which means it's got to be positive. Okay, now we're ready to go to step 3. Set each of the factors on the top and each of the factors on the bottom equal to 0 and solve for x values with which we will partition our number line, our x number line. First factor on top, negative 1 equals 0. That's nonsense. We're not going to use that. For x plus 3 is equal to 0, x equals 0, x plus 3 is equal to 0. We took each factor, set it equal to 0. The first one's nonsense. The second factor on top gives us a result of x equals negative 3/4. The first factor on the bottom gives us x equals 0. The second factor gives us x equals negative 3. So we are going to use these values, negative 3/4, 0, and negative 3, to partition our number line into regions where we will test a value for x in our entire fraction to determine the sign, positive or negative, of each of the factors, and then finally of the entire fraction in each region. So first, for step 4, 5, and 6, we'll write negative 1 times 4x plus 3 over x times x plus 3. And here's our x number line. And we're going to partition it with these numbers. The smallest is negative 3. The next to the smallest is negative 3/4. Then we have 0. We put them in order from smallest to largest. And then in each of these regions, we're going to put the factors of the entire fraction. Now the first factor is always going to be a negative because negative 1 will never change no matter what value we choose for x. Then there's another factor on top and 2 factors on the bottom. I'm just going to make the little parentheses to identify those factors. Now I'm going to choose x values in each region. For the first region, that's values of x smaller than negative 3, it's most convenient to choose something like x equals negative 100. Plug that value in for x and see what you get for the second factor on the top. 4 times negative 100 is negative 400, plus 3 is a negative result. So on the top, we have a negative number. for the second factor. For the bottom factor, of course, when x is negative 100, we get a negative for the first factor and a negative for the second factor. Now we just have to determine what's happening for the entire fraction. So we've got two negatives on the top, and we have two negatives on the bottom. So the top is a positive, and the bottom is a positive. Okay, that means a positive over a positive gives us a positive. That means the entire fraction is positive in that region. Now for the next region, between negative 3 and negative 3/4, we have to choose a value. What would be a good value to choose there? I guess x equals negative 1 would work, because that lives between negative 3 and negative 3/4. Let x equal negative 1. Of course, the first factor is negative. We've already said that. When x is negative 1, we get 4 times negative 1 is negative 4 plus 3. That's a negative result. The bottom, we have x is negative for the first factor on the bottom, and for the second factor, negative 1 plus 3 is positive. So the top gives us a negative times a negative, which is positive. The bottom gives us a negative times a positive, which is negative. Positive divided by negative gives us a negative result for the entire fraction. Now for the region between negative 3/4 and 0, we can choose negative 1/2. Negative 1/2 lives between negative 3/4 and 0. Plug that in there for the first factor is still negative, of course. The second factor, 4 times negative 1/2 is negative 2. Negative 2 plus 3 is positive. So the second factor on top is going to be positive. The x is going to be negative 1/2. And then the last factor, negative 1/2 plus 3 is positive. So on the top we have a negative times a positive. That's negative over the same thing on the bottom, negative. A negative divided by a negative is a positive. And finally, for the region to the right of 0, for x values larger than 0, this will be easy. We'll choose x equals 100, plug it in. We get a positive for the second factor on top. We get a positive for each of the factors on the bottom. So the top is a negative, the bottom is a positive. A negative divided by a positive is negative. Whew. Wow, that took a while because there were 4 different regions. But we can see, notice that the signs of the entire fraction alternate in each of the regions. You should never depend on that happening. There might be situations where that doesn't happen, so you should always carefully check by making a careful sign graph like we did here. All right, moving on now to step 7. Step 7 reminds us that in step 2, it said that the fraction had to be positive. So we are only going to shade x regions on this number line that gives us the entire fraction being positive. That occurs in the first region. We'll shade the first region. It occurs again in the third region. Don't shade the other regions because they gave us a negative result for the entire fraction. We're only interested by step 2. We're only interested in the entire fraction being positive. And finally, in step 8, we want to determine whether we should include or exclude the endpoints when we do the brackets, and the boxy brackets or the round brackets. Well, this original problem came with an inequality sign in step 1 that had an equal portion in it. It was greater than or equal. That means we're going to include the endpoints, but not all of them, only the ones that do not make the bottom of the fraction equal to 0. The bottom of the fraction had an x and it had an x plus 3. So the values of x that will make the bottom 0 are x equals 0 and x equals negative 3. Those are the x values that are going to get round in brackets, not boxy brackets. We're going to exclude those x values at 0 and negative 3. So go back up to the graph, put a round bracket on negative 3, a round bracket on 0, and an arrow on the negative infinity, and a boxy bracket on negative 3/4. Now our conclusion is, from the graph, the solution to this problem is the open interval from negative infinity to negative 3 open interval, union together with boxy bracket negative 3/4 to 0 open interval. And we are finished.